Dear students, welcome to today's lectures on transforms and boundary value problem subject unit 1 PDE. So many students are asking how to understand the ODE and PDE concepts. What is the difference, major difference? So I am asking one question. This is some real life exam related with how to understand the ODE and PDE concepts. Why is a heater rod ODE but a room temperature PDE? So this question gives the proper explanation and understanding about what is actually ODE, what is actually PDE. So for example, for ODE, I'm taking one iron rod. So the welding process going on. The welding process going on. So at the time of 10, this portion will get heat. Next at the time of 10:30, this up to this portion will get heat. Next after half an hour, only approximation about. So after half an hour, approximately 11 o'clock, the full rod getting heated. So here the temperature is going on here at a different time. So how can I write this equation? So the temperature is going on with respect to the time. Yes, so I shall represent this one in terms of dt by dt. So d is a temperature. This small t represents time. This one is a temperature. So I can write this action in terms of dt by dt. The temperature is going on at particular time, then particular time of 10:30, then after half an hour of 11 o'clock, it's reached the full rod getting heated. So I can write this one in terms of dt by dt. Suppose we heat a metal rod at one end. If we study how the temperature changes with only with time at one fixed point, then the temperature depends on only one independent variable time. So this leads to the proper explanation about ODE. Do you understand? This explanation is enough to understand the ODE. If I write this equation, heating a metal rod at one point, the temperature changes only with the time. Yes, only with the time. So I can write this equation dt by dt equal to minus k t minus Ts, which means T is temperature of the rod, temperature of the iron rod. Next, small t, we know time. Next, Ts, surrounding temperature. Next, K, constant. So, since the temperature depends only on one independent variable time, the denominator variable is independent variable, numerator is dependent variable. So, temperature depends on time. That's why this is dependent variable. T, time, independent variable. Since the temperature depends only on one independent variable time, this is an ordinary differential equation. So you can understand from this small explanation for ODE. So try to understand the concept. You are heating the metal rod. So the heating process starts with at one end. So particular time throughout the entire heating rod will getting heated. So the temperature depends on the time only here, only one independent variable. So we have to write this entire equation in terms of dt by dt equal to minus k into t minus Ts. This is for explanation for ODE. Next we have to say about we have to discuss all about PDE. So here consider example of room temperature in classroom or your one particular room temperature. So in classroom means many students were sitting, nearly 50 students are sitting, and also inside the classroom the fan also nearly 5 to 6 fans. If big hall means 5 to 6 fans with AC, and then this is also will change the room temperature, and then human body temperature also will change the room temperature, and also if the room door is opened, this is also will decides room temperature. Yes, sir. So people around nearly 50 people sitting inside the room. The external sources of fan, light, AC, everything is switched on. Then classroom door also opened or closed. It is also decides the room temperature. So why I'm saying this one means you can easily catch with real life examples what is PDE actually. So um, now suppose we want to know the temperature at every point in a room. Every point in a room, the temperature depends on position where you are in the room. The temperature depends on the position where you are in the room. Did you catch where you are in the room? The temperature depends on position where you are in the room and also on time. So it is affected by AC, fan, lights, people, human body, temperature, and windows, the door, and many other factors. Without anything, even atmospheric also will change. So since the temperature depends on more than one independent variable, I'm saying AC, fans, lights, human body temperature, windows, doors, everything is a external source and also many other factors. So, since the temperature depends on more than one independent variable, it is a partial differential equation PDE. So, instead of saying this one, denominator will vary. Okay, a denominator will vary. So, the temperature depends on more than one independent variable. It is called a PDE, such as position and time. So, the mathematical reason means if a quantity depends on only one independent variable, we use an ODE. Only one. Only one independent variable. If it depends on two or more independent variable like fan, AC, light, windows, human body, human body temperature, human body temperature also will affect their own temperature. So two or more independent, this represents denominator will vary. Two or more independent variable such as space and time. So because this decides this, if and light, everything decides space and time. So we use a PDE because of space and time. So these analogies understand the mathematically what is actually PDE and the ODE explanation. So for ODE, temperature changes only with time, but PDE temperature changes with position and time. Okay, so for example, for PDE, for PDE, temperature inside a room. So this is partial dou T by dou T equal to alpha of dou square T by dou X square plus dou square T by dou Y square. So this is temperature dependent variable independent X and Y. This here temperature position and time, where temperature equal to T of xyz position and time, xy position, which means may be considered as your position, your sitting area. So small t time. So here the temperature depends on position xy and time t. So this is a partial differential equation because denominator will vary. So ODE, some simple explanation. So ODE dy by dx equal to 2x. So here only one independent variable x only there. In PDE, these are the examples to understand simple ODE PDE concepts. In PDE, if I am writing dou z by dou x plus dou z by dou y equal to 0. So here two two independent variables are there, that is x and y. This is the small understanding examples of ODE and PDE. So try to understand from these two concepts with these two explanations. So finally, I'm saying about, and then one more thing, in integration, we are using that plus c. Why this plus c coming? Yes, why this plus c coming? So many students are asking about this one. So imagine 1 kg cake. Imagine 1 kg cake. If we cut the 1 kg cake, if we cut into many tiny pieces, it is like differentiation. So many tiny pieces in different shapes. This is differentiation. This is differentiation. We are breaking the whole into smaller parts. If we collect all the tiny parts, we collect all the tiny pieces of cake and join them together. It's like a integration. So we are reconstructing the whole from its parts. Understand? We are reconstructing the whole from its parts. So this is the basic understanding, and also funny kindergarten type explanation. Take 1 kg cake, cut into tiny pieces. So there are tiny pieces if you are cutting it, that is differentiation. If you are again if you are adding all pieces, that all tiny pieces, join them together, it is like an integration. So a small explanation. And also in integration, we are using that plus c. Why this is coming? Many students are asking. So the plus c, the reason behind the plus c is, if we differentiate the constant, if we differentiate the constant, one constant, it becomes 0. For example, x equal to 5, we are differentiating, if x square equal to 5, we are differentiating means to x equal to 0 will come. So x equal to 0. So okay, this is okay. Therefore, when we integrate, we cannot. So come to this part. So in differentiation, the constant directly becomes 0 in any equation. But in integration, we cannot determine what constant was originally present. That is actual truth. What constant was originally present. So we write plus c called the constant of integration. So if you are integrating this equation, you will get 2x. So plus 5 becomes 0. and x square, 2x square by 2, 2 will cancel, plus c. Okay, well, so the constant is there because many different functions have the same derivative. Okay, so what is actually reason? When we integrate, we cannot determine what constant was originally present. So we write plus c is called the constant of integration. The constant is there because many different functions have the same derivative. Okay, this is the small explanation about ODE and PDE and integration differentiation. Thank you, students. And also, we have to explain ODE and PDE in many real life examples. For example, consider the cup of tea. Such a hot tea. Suppose I'm making tea in 1 cup. I only check how the temperature changes with time. How the temperature changes with time. This is ODE. And then, now imagine a hug bucket. A hug bucket of tea. The temperature at the top, middle, and bottom is different. The temperature at the top, at the bottom, top, and the left and right, if any point, if I'm checking, the temperature is different. It is also changes with time, but this is PDE. Do you understand these two difference? And also, one more explanation about this. I'm standing in your classroom. If any person standing in classroom in one place and measuring the temperature every minute it depends on only on time. It depends only on time. It's a ODE. Now come to the PDE. Now I ask every student to measure the temperature at their seat. Now I ask every student to measure the temperature at their seat. Students near the AC feel cold. Yes, student near the AC feel cold. Those near the window feel warm. Those near the window feel warm. And the temperature changes with time too. This is PDE. Okay, so this is a small clarification about ODE and PDE, and also for integration differentiation also we have to clarify about this. For example, if you order the pizza, so cut in 8 portion, that is called octant, because you will get the shape of one piece. So the whole pizza cut by 8 pieces. So you order a pizza and cut into 8 slices. Each slice represents a small part of the whole. So just as differentiation studies, small change when everyone put the slice back together. You recover the whole pizza. Yes, you recover the whole pizza, just like integration. For differentiation, imagine a dairy milk chocolate. If we break it into many tiny pieces, that's a differentiation. If we collect all the pieces, put them together, back together, that's an integration. So mathematics is easier than putting a broken chocolate back together. Yes. So those types of examples make you strong in PDE and ODE differentiation integration clarification. Thank you.